Good evening. I'm trying a new experiment with an app called Explain Everything that I can upload to YouTube to try to give you an overview of the unit briefly to kind of help you a little bit because I think some of you are not watching the videos and some of your homework assignments are low. So I'm hoping that maybe by using this app and creating this video that when you go into announcements you can see it. So if some of you haven't gotten Unit 1 done yet, this is going to be a Unit 1 overview and then I'll work on Unit 2. So let's begin. All right, so a couple things that we're going to talk about right now is notation first. So the first thing about notation, there's a couple things you have to be aware of, and it comes up quite a bit. First of all, when I see something that says this right here means a line segment AB, or segment AB. Sorry, my B is not writing. Sorry about that. Okay. If the AB is just by itself, that means the length or the distance of AB. If there's nothing above it, it's implying a distance. Distance is a number. It's a numerical answer. If I just see this right here, this means a plane. With a plane, three non-collinear points make a plane. What is collinear? Co means they exist together. Line means lines. They exist together on a line. So three that are not on a line together create a plane or an imaginary plane in weird spaces of time. It's one of the most confusing things you'll do. With the three letters making a plane, if I put an angle symbol in front of it, now I've got angle ABC. If I put a triangle in front of it, I have triangle ABC. If I write ABC by itself and I don't put something in front of it, I think you're referencing a plane. Okay, notation's important. Intersections. It's really important to understand how things intersect. If I have two lines that cross are going to cross at a point. Planes are weird. If I have two planes, and no, I'm not an artist, so you're going to pretend you know what I'm drawing here. I have these two planes that kind of cross. Where they intersect, which we're going to pretend is right here, they're going to come together and they're going to form a line. Two planes might look like it's a line segment, but it's not because they can go on and on and on forever, so they always produce at a line. Then if I have a line in a plane, they're going to produce at a point. Why? Because that line is piercing through that plane, so they're going to intersect at a point. The next thing we're going to talk about is segment addition postulate. Some of you had some really weird answers for these questions. If I have this line, ABC, the segment addition postulate just says we're going to add the segments that are next to each other together to get a total distance. So if he's x and he's 2x, and I know this whole distance here is 21, or 20, sorry, then I know that x plus 2x is going to give me this distance. If I want to find the value of x, the value of x is a number. It's not 2x, it's not 3x, it's a number, it's a numerical value. So here, when I do like my like terms, this is a bad choice, I should have done 21, then x here equals 20 divided by 3. So then if I wanted to know segment AB, well AB happens to be that value, but BC is 2 times that value, so it'd be 40 over 3. The difference is you have to understand what you're looking at. So the segment addition postulate just adds segments together. I got some funky answers from people from that, so I'm assuming they did not watch the video. Okay, moving on to midpoint and distance formula. The midpoint formula tells us that we have x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Oops, by 2, sorry. Now, when I have this midpoint formula, If I have ordered pairs, that's where they're getting the x1 and x2 from. In my ordered pair, this is my first ordered pair, so he's x1, y1. This is my second ordered pair, so he's x2, y2. If I had a third ordered pair, it'd be x3, y3. So that's where they're getting these x1s and x2s from. They're not squared values. They're just basically subscripts identifying where they sit. So now, when I go to use my midpoint formula, when you have the number line, all you're doing is counting those spaces in between everything. If you're going from -9 to 4, you're counting 9 to 0, and then 4 more, it's going to give me 13. It's just saying, when you're talking about a line being linear, with the midpoint, it's just the x values. So you had that whole big, 13, you just divide it by 2, there's the midpoint. Midpoint does not mean it lies between. Okay? It has to come out and tell you it's a midpoint to know that it's in the middle and it's congruent on both sides. If it's just between the two values, being between the two values is just the segment addition postulate. It's saying AB plus BC is the whole distance. There's no congruence whatsoever. When you get to midpoint, you have congruence because midpoint means that here I have the segment AC. If B is the midpoint, then these two pieces are congruent. That little slashy means they're congruent. Now, with that as well, if I say something bisects the segment, it does the same thing. Bisect and midpoint virtually mean the same thing. It's just different vocabulary for the same thing. Geometry is all vocabulary. So if I come in here and put in values, let's just say I have 1, 2, and I have 3 and 4, and I want to go ahead and find my midpoint, it's just 1 plus 3 divided by 2. 2 plus 4 divided by 2. So what is 3? That's 4 halves, so that's 2. That's 6 halves, that's 3. The midpoint is this ordered pair, 2, 3. Now with distance, and if you're looking for the end point, it's a different setup. If you're looking for the end point, that's a different setup. I don't have room on the slide to go over that, but if you need me to, I can. It's just saying that it equals the midpoint, so you have to make each one equal to the midpoint. Most people didn't miss that one, and that's the harder one. Some people miss the midpoint. With distance, distance is a square root of x1 minus x2 squared plus y1 minus y2 squared. What people are forgetting to do is take the square root. If it wants an exact distance, it wants you to leave it as the square root and simplify the radical. If it wants an approximated distance, it wants a decimal. On some things, I've allowed you to do either one. The angle addition postulate is basically the same thing we did before. It's adding two angles together. It has nothing to do with bisecting. It has nothing to do with anything. All it is that I have two angles next to each other. I can add them together to get a total measure. And don't assume, because the biggest thing in geometry is assumption, that just because that right there looks like it might be a right angle, it is not a right angle. Unless I put a box to indicate the right angle, or I tell you it's 90 degrees, you can't assume, oh, he looks like he's a 90 degree. Well, I look like a rock star, and I am not. All right, and so speaking about our angles, we have four angles we are going to identify. One is complementary. Complementary means that there are two angles whose sum is 90 degrees. They do not have to be adjacent, although a lot of times we see them adjacent. You would have to see the little 90-degree box there. So if I told you he was x, and I told you he was 2x, then complementary angles say, okay, x plus 2x is going to give me 90 degrees. If I asked you to find the value of x, I would then solve it to get x. I might just tell you I have a 20-degree angle. What's its complement? Well, 90 minus 20 makes its complement 70 degrees. Supplementary angles, the two equal 180. So it's the same idea, except for anything that equals 180 is a straight line, because straight lines are 180 degrees. So if something's a straight line, automatically it's 180 degrees. If there's two angles on it, then automatically they're supplementary. So again, I could set up, I gave you a 110-degree angle, its supplement would be 70 degrees. A lot of times they'll say, what is the supplement of? Or the two angles together are supplementary. They also do not have to sit next to each other. We just always tend to draw them because that makes it nice and pretty. So if they happen to sit next to each other, then we have this linear pair. All a linear pair is an adjacent supplementary angle. And with that, if I tell you they're a linear pair, I know they're 180 degrees. That's it. And last but not least, vertical angles. Vertical angles are two angles. I have intersecting lines, and they're two angles that when these two cross, they're going to be opposite of each other, and they're going to be adjacent. And they're opposite, not opposite and adjacent. They're opposite and congruent. So here, this angle is opposite of this angle, so they are vertical angles. This angle is opposite of this angle, they are vertical angles. It's when two lines cross, these vertical angles always happen, and when they happen, they're always congruent. It's the one thing you're going to look for 1,000,000 times in 10,000 of these pictures that we have. If I have these angles, vertical angles pops up everywhere. All right, this was just a short and sweet overview to see if this would actually work when I put it to YouTube. So anyway, hope this helped. Thank you.